Okay, today we will discuss wired LANs. Okay, wired Ethernet LANs. Like wired means which are connected one. Okay, wireless means which are not connected one. We will start fifth module today. Like IEEE standards will be discussed today. Like for all the Ethernet LANs. Okay. In 1985, the Computer Society of IEEE Standard, like Institute of Electrical and Electronics Engineers, started a project. The project called 802, okay, which is a standard given to IEEE, like Ethernet standard, to set standards to enable intercommunication among equipment from a variety of manufacturers. Okay, we have plenty of manufacturers which are evolved from later onwards, like 1985. uh, Project 802 is a way of specifying functions of physical layer and the data link layer of major LAN protocols. Okay, we have major LAN protocols under data link layer, as we discussed in the previous session, like random access protocols and carrier sense multiple access protocols, and we have channelization. Okay, these are the three important protocols we discussed in the previous module, like in the data link layer, right? And will be discussed here data link layer and physical layer, few of the standards which are comes under IEEE standards, right? Okay, first before going to the IEEE standards, just we need to discuss about what logical link layer and what MAC layer. Like the data link layer, DLL, the data link layer in the OSI model, which is a second layer, like a physical layer. After physical layer, we have a data link layer. In an IEEE standards is divided into two sub layers. Okay, the data link layer will be divided into, according to IEEE standard, into two sub layers. One is logical link control and medium access control. Okay, logical link control, that is LLC, and medium access control, that is called MAC. Okay, first one is we have logical link control, LLC. In IEEE project 802 point, flow control, error control, and a part of framing duties are collected into a one sublayer called logical link control. Okay, so in data link control, DLC, we have discussed all these, like what do you mean by flow control, what do you mean by error control, and what are the various methods which are used to control flow as well as error. Okay, the previous module we discussed this. Okay, again it will be recalled here, like IEEE standard which comes under logical link control. Okay, and framing is also handled in both LLC and MAC sublayer. Okay, framing, like when you create a packet or a group of data, framing is nothing but group of data which contains few elements, like few fields, source address, destination address, and header field, and FCS, like frame check sequence. Okay, these are the different fields which will be contained in the frame. Okay, that will be mentioned for both LLC and MAC, MAC, means like medium access control sublayer. The logical link control provides one single data link control protocol for all the IEEE LANs. Okay, in LLC, logical link control of data link control, we have only one protocol which controls all the IEEE LANs. Okay, but in this way, LLC is a different from medium access control. Okay, which is different from MAC control sublayer, which provides different protocols for different LANs. Okay, yes, because that MAC layer, medium access control layer, we have random access, medium access, multiple access, and channelization. Okay, so there are three different protocols, and even in that we have a different sub protocols like CSMA, CD, Aloha, right? And channel TDMA, FDMA, right? CDMA. All these are called time division, code division, and frequency division. Okay, there are different protocols has been categorized under MAC sublayer, right? Next is framing of LLC defines a protocol data unit. Okay, framing of LLC defines one field called PDU, protocol data unit. That is somewhat similar to the HDLC. HDLC means high level data link control. Okay, high level data link control. There is one framing method we discussed in the data link control. Okay, for example, it defines CSMA like carrier sense multiple access collision detection as the medium access method for Ethernet LANs. Okay, in that topic also we discussed. Okay, the few LANs are used CSMA CD concept of under medium access method, and token passing method for token ring, and token bus for LANs also used in token passing methods. Okay, so that's why LLC and MAC sublayers are differ, because only one protocol used for LLC control protocol means a logical link control protocol. Okay, but in medium access control layer sublayer, we use each Ethernet separate protocol. Okay, every Ethernet there is a separate protocol will be used. Best example is in medium access method we have CSMACD that will be used for Ethernet LANs. Okay, and token ring for token passing methods, right? So next is we have IEEE standards for LANs, and we have OSI model. Okay, and IEEE standard. Okay, we are just comparing here, means of comparing between the OSI model and IEEE standard model. Okay, the logical link control is and medium access control. These are the two sub layers under data link control layer. Okay, see here we have here data link layer, physical layer, and upper layers like network layer, transport layer, session layer, presentation layer, and application layer. Okay, so we have transmission medium at which is connected to the physical link physical layer of the each and every OSI model. Okay, and when you come to IEEE standard, the physical link here consists of Ethernet physical layers, token ring physical layer, and token bus physical layer. When you come to data link layer, okay, data link layer, we have divided into two types. One is logical link control layer, and that will be used only one protocol, LLC protocol. When you come to medium access control, we have different Ethernet and different token ring, token bus. Okay, we have different protocols might be used for different applications or different LANs. Okay, Ethernet LAN, token ring LAN, and token bus LAN. Okay, in physical layer. When you use some protocols at data link layer, Ethernet MAC, and token ring MAC, and token bus MAC protocol. Okay, like this so on. For every different Ethernet, different protocols might be used. Got it? So next is HDLC, like higher data link, high level data link control layer, high level data link control frame compared with LLC and MAC frames. Okay, our HDLC is having address like source address, destination address, control information, upper layer data. Okay, like data link control layer means data link layer. Above that we have a network. From network there is a packets received in the form of packet, the data will be, and which will be generated or reformatted as frame, right? Okay, that frame is consist area, and FCS means frame check sequence. Frame check view sequence. These are the various fields for HDLC. HDLC frame, high level data link control. Okay. Our data link control is again divided into two types. One is LLC, that is PDU, packet data unit, sorry, protocol data unit, LLC protocol data unit, and which consists of DSAP and SSAP, destination service access point and source service access point. Okay. See, whenever you create a Wi-Fi in your homes, definitely for every 10 meters or 15 meters, there might be a access points for effective use of our bandwidth. Okay, like to access a Wi-Fi, we need a access points. Even for logical link control protocols, again we need a source access point and destination access point, where we can the connection must be established very effectively or very strongly. Okay, these things will be used, DSAP and SSAP. And one more sublayer is called MAC frame, medium access frame, and which contains MAC header and MAC payload and FCS. Okay, MAC header, like medium access control, there will be a header like to identify when the frame starts, when the frame ends, to differentiate between various frames in the transmission medium. We need a header. Okay, and again we have a payload which contains the combined data of our upper layers, and FCS means frame check sequence. Okay, similar to HDLC, in Mac also we have frame check sequence, like what is the frame sequence, like 0 1 2 3, or some naming you are given, right? To check that frame sequence, we use this field. Okay, these HDLC and LLC and MAC frames, which are contains destination and source MAC addresses. All are contains destination and source MAC addresses as its first two fields. Okay, as it first two fields. The middle section of the frame is payload, which payload data, which includes any headers for other protocols. For example, Internet protocol, which carries in the frame. The frame ends with frame check sequence, that is FCFS, which is 32-bit cyclic redundancy check. Like, is there any bits changed? Okay, in frequency, sorry, phase frame check sequence, is there any bits which are changed due to some error corruption or bits corruption? Okay, that will be identified by using CRC, cyclic redundancy. We have checked, right, by using checksum how our encrypted data, whether it is corrupted or not, like data word, which will be converted into code word, and code word reaches at receiver end. If any bit corrupted, okay, which is identified through cyclic redundancy check. Okay, if syndrome or our remainder, if it is zeros, then the frame is not corrupted. If any bit is changed, then there is a corrupted of the sent data. Okay, like that, by using cyclic redundancy checks, we identify the frame whether it is corrupted or uncorrupted. Okay, cyclic redundancy check is used to detect any in transit corruption of data. Okay, so that's about how layer or data link control layer is divided into two sublayers, and how it is representing through frame format. Okay, and their explanation we have done, right? So next is we have standard Ethernet. The original Ethernet was created in 1976 at Xerox's Palo Alto Research Center, Park. Okay. Since then, it has gone through four generations. We briefly discuss the standard Ethernet in this section. Okay, we have four different versions or sections. Okay, these different generations have been evolved later onwards, like 1976. Later onwards, the Ethernet standards are evolved. The four generations. Those things will be discussed here. Okay. So the Ethernet evolution, there are four generations. One is standard Ethernet, 10 Mbps, and fast Ethernet, 100 Mbps, and gigabit Ethernet, 1 Gbps, and 10 gigabits, 10 gigabit Ethernet, that is 10 Gbps. Okay. See, as we know, when we using means when you take past 10 years, past 15 years, what was the bandwidth increased, right? See, when we are in when we are studying the engineering, kbps means that is most emerging bandwidth. Okay, later it becomes mbps. Now it is gbps. Okay, 1 gb, 2 gb per day itself. For mobile phone itself, we are giving 2 gbs, 8 gbs and all, right? Data pack, right? See how much the bandwidth is evolved, right, in the ethernet lands. See, when it might be for 10, 5 years back, kbps, mbps it was there. Now it becomes gbps. This is what the evolution of the ethernet, evolution of generations. Okay, four generations, and we'll discuss one by one with its functionality, internal functionality. Okay, 802.3. See, the version has been evolved. Like 802 is the project. From that, it is evolved like 802.3. There is a MAC frame, medium access control frame. Okay, which is preamble is 56 bits of alternating ones and two zeros. Okay, this MAC frame contains preamble is 56 bits that will be again divided into different fields. Okay, so next is a start frame delimiter and flag. Okay, so the beginning and end to identify the individual frame in the channels means we need to give some identified values or identified bits. Okay, to identify we may give start frame delimiter, start frame delimiters. Delimiters can be mentioned at both the ends of the frame to separate each frame. Okay, or else you can give flag bits like 100, 10, okay, when this is the bits identified continuously 8 with this format, this means that whether it is a starting frame or ending of the frame. Okay, so when you give a preamble and start frame id as 8 bits, preamble is 7 bits, 56 plus 8, okay, 64, right? 64 bits. That is called physical layer header. So later we have 6 bytes of destination address, 6 bytes of source address, and there is a length or type of the frame, and inside we have a data and padding. Padding is nothing but if you have any additional data, okay, like along with the header information, it will be header of the data information, it will be added. That's called padding. Okay, next is crc, cyclic redundancy, that contains 4 bytes. Okay, that contains 4 bytes. Okay, totally how many bytes? 4 plus 2 6, 6 is 18, and 18 plus 8 is 26, and 26, and this may contains hundreds of bytes. Okay, data and padding contains hundreds of bytes. Okay, totally it might be a 64 or 128 or 512 bytes of frame length. Okay, these are the various fields for mag frame. Okay, next is maximum and minimum lengths. Minimum and maximum length, as I told no previously, the minimum frame length is 512 bits or 64 bytes, and the maximum frame length is 15 uh, 1518 1518 bytes. Maximum length of any frame is 1518 bytes or 12144 bits. Okay, minimum is 64 bytes. Okay, so apart from this 8 plus 6 14 20 22 and 26 plus uh, this is 48. Okay, this is what the frame size, and that will be depicted here. What is the maximum size and maximum length and smaller length of your see payload means which is containing both data and padding addresses. It is payload length. It is 46 and 1500 bytes and 46 bytes minimum, and maximum is 1500 bytes. Frame length minimum 64 bytes, that is 512 bits, and 518 like 1518 bytes, that is 12144 bits. Okay. Example of Ethernet address in hexadecimal notation. Example of Ethernet address in hexadecimal. Okay, C, B, D, A, all these are all hexadecimal numbers. Okay, this is 6 and 1, 2 and 1 and 2. C means C is 13. Okay, C is 13 like 22, 13 and 4B means 13, 12. Okay, B is 12 and A is 11. 11, 12, 13 is C and 14 is D. Okay, like this you can perform. 6 bytes plus 6 bytes is equal to 12 hexa into digits. 12 hexa digits is equal to 48 bits. 12 6 12, 12 into 4 is 48. Right? This is the hexadecimal format. And when you tell unicast and multicast, for unicast 0, multicast is 1. Okay, unicast is 0, multicast is 1, which is mentioned like when you mention the beginning 0 means that is performed as unicast. When you mentioned the bit is equal to 1, that is performed as a multicast. Unicast means one system to other system communication is happening, that's called unicast. When you multicast means one system is sending and receiving data towards and from many devices is nothing but multicast. The least significant bit of first byte defines the type of address, and if the bit is 0, the address is unicast. Otherwise, it is multicast. What we discussed, same thing explained here. Multicast identifies logical groups of computers. Okay, we have a set of computers which are connected, and those logical addresses or logical identity is having, and a single message can then be sent to the group. See, for example, we have one group. When you put one message into that group, so many people who are members of that group can access the same message, right? That is called multicast. So next is Broadcast is a packet that is sent to all devices on the specific network. Broadcast means there might be a network. When you put one packet into the one device, it will be broadcasted, or it will be circulated, sent to all the devices on the specific network. Broadcast destination address is a special case of multicast address in which all bits are ones. Okay, the lower level means lower case bit, or least significant bit. When you uh, when you see it is one, then that is called multicasting. Okay, define the type of following destination addresses. Okay, to find the type of addresses, we need to look at the second hexadecimal digit from the left. If it is even, the address is unicast. If it is odd, then the address is multicast. If all digits are f's, all digits are f, the address is broadcast. Okay, and therefore we have the following, and this is unicast address because a in binary is 1010 10. Okay, 10 is a, 1010 definitely, which is 0. It is even, so that's why it is unicast. Address is even, then it is a unicast. B is the multicast because 7b double e, which is a 7 and 0111, and definitely which is a multicast. And C is a broadcast because all digits are F's. Okay, all digits are F's. Show how the address 4721B, 2E, and 08 and double E is sent out on online. Okay, the solution is the address is sent left to right, byte by byte. From For each byte, it is sent right to left, bit by bit, as shown in the below. Okay, like whatever bits mentioned here, that will be converted into binary. Okay, this is hexadecimal, that will be converted into binary, and this binary data will be passed on to the left to right or right to left. So next is categories of standard Ethernet, like 10 base 5, 10 base 2, 10 base T, and 10 base F. Okay, what are the different twisted pair cables will be used? All those things we'll discuss in the next class. Okay. Today we discussed Ethernet, the standards, as well as how the frames are representing.